Okay, I think we're live. I definitely messed up the configuration, so I need to here's what we'll do. Alright, I just posted that we are live in the other chat that I was using, and I will now mute myself. Right, so I think it's all figured out. Let's give it like one more minute now because I messed this up, and then we'll get started. So let's do it like 5 minutes. Get started. All right, we have viewers. That was actually 2 minutes. So that's good. It's exciting. First live stream. Minimal technical difficulties. Four viewers. Big time. This is now the time when you say like and subscribe. Okay. I'm just gonna get started. Hello, everybody. All 4 folks on the internet who've joined so far. So that is exciting. Basically, I was thinking that today we could do a full rundown of, okay, there's a conference. Well, first of all, there's a universe of conferences, some of which be interested in reading papers from. How do you decide the universe of conferences? Then there is basically, once you decide the universe of conferences, what conference do you want to read papers from? How do you actually even decide which papers to read? I'll talk about how I decide which papers to read from some of these conferences. And then also, how do I actually read the paper? So we'll probably go for a few hours tonight. I've actually already looked at one conference in particular, NSDI, which stands for Networking Systems Design and Implementation. Networked Systems Design and Implementation. It was in April. And I actually have created a list of all the conferences in 2023 that I was interested in reading papers from. And I'll read papers from the conference, but I won't always write about them. And that's because writing requires a bit more time than just skimming the papers, and not all the times do I really want to write about something. So anyways, I'm trying to get better at writing, which I think the data shows the pace of paper reviews has increased. So anyways, NSDI was in April, like I said, and there are a few other conferences that are in between. We are here. OSDI, Operating System Design and Implementation, is coming up next week. Really exciting. There are going to be a lot of really good papers from that, and I will post about them someplace. I think it will probably continue to be Twitter still, but who knows? Threads, whatever, the internet. So, anyways, I built up this list over time. I actually initially seeded the list with conferences that I knew about, and then there was somebody else who used to write about academic CS papers in the past. His name was Adrian Collier. He had a blog called themorningpaper.com. I'm gonna utilize the chat for the first time. So let's see. Does YouTube www? Do I have to type in the full URL? The morning paper? Hopefully that's the right URL. Nope, the morning paper. Okay. So this is actually what it is. The actual link. So he had a list of conferences that I looked at. They're conferences that I knew about. He didn't read papers from all the conferences that I was interested in. I'm also interested in other things. For example, I was interested in biology, computational biology, so there are conferences related to that as well, or proceedings that come out. So anyways, I have a list of conferences, and I create it at the beginning of the year, and then I just look at the conferences that are happening. So NSDI, that's this one. A lot of interesting papers here. I'll go to the conference page, and then I will look for a place where it looks like all the papers are going to be. So for example, technical sessions, that's a good one. Accepted papers, also another good one. I know from experience that it's going to be technical sessions. Something that's very nice. Oh, there, okay, it's loading. Something that's really nice. So the organization that runs this is called Invisinets, and they make all the papers and all the videos available for free, which is awesome. This is not true of other proceedings. For example, ACM has some conferences like SIGOPS or SIGCOM, and they don't necessarily make the papers available for free, but if you're a student or you have an employer your employer might have access as well. So generally I recommend, lighting. We need to work on lighting for next time. First time. So generally recommend seeing if your employer has access, because most employers have access to the ACM, or most larger employers rather. And there's also one hack, which is that if you do some community college course, for example, or some maybe smaller college course, then you can also get access to the papers that way through the library. So, and sometimes even depending on the library that you have, they might also have an ACM subscription. So generally there's a way to get to the papers. It is a bit unfortunate that some of the papers are locked behind that paywall. Different conversation, but thankfully Invisinets has all the papers online. So that's awesome. Okay, so you have a list of the papers. How do you decide which ones you're going to read? There are a few things that I look at. One of the things I look at is there an author that I'm familiar with from reading their past work, or maybe there's a lab that does research in an area that I'm familiar with from reading past work. I'll go through what some of those examples are, because there are some in here already. It's worth noting that I've already looked at some of the papers, so I have a sense of what I want to read. And I also have a sense of which paper we'll probably be reading today. But yeah, is there a person or a set of authors that have some research that I'm generally interested in? Then the other things I will look at are if there's an area that I'm interested in learning more about. Like I know, for example, RDMA. There's this technology, RDMA, which stands for Remote Direct Memory Access, and it is really interesting, and it is being used more at scale. Okay, I don't know anything about RDMA, or I know relatively little about RDMA. What are people doing with it, and what is the cutting edge of RDMA? So, subject matter. If there's something I know that I don't know about and I want to go learn about it, then there is also awards. So many of the conferences will have a best paper award or a community best paper. So people have decided that, the committee generally have decided that this is a good paper to read, or it's a paper that they're impressed by in particular, and so they'll highlight it with an award. So that's another way that I will, that catches my eye. And then alternatively, if there's something that I know I've never heard about and I know nothing about it, that also is a way that I find papers. Because it's like, there's a whole track in the conference about this thing that I know nothing about. I'd be interested. Why don't I know anything about it? If I could learn something about it, that'd be cool. So that definitely happens for me. So let's see. Is there a way to pull up chat? There's some. Okay, getting used to the chat interface. Folks have any thoughts? Please write in chat. I'm also thinking, what is the best way to have live stream paper reviews in the future? Is it actually YouTube? Is it Discord? Is it something else? So I'm open to feedback because I definitely want people's thoughts. Okay, so I think that was most of the ways in which I decide what papers to read. There's also organizations. So if there's some industry group that I know is doing research or that I've read research from in the past, some examples would be ByteDance, Alibaba, Microsoft, Meta, Google. things along those lines. So I'm not sure. I think that actually might cover most of the organizations, like industry applications here. Sometimes there are actually startups that will publish some research, which is also very cool. So anyways, that is that. So just looking at some of the papers, there are a few that I've already called out. So the first paper that I've actually already read, so probably won't be live streaming or reading it, is Empowering Azure Storage with RDMA. So I actually know relatively little about RDMA, but oh my gosh, look at all the authors on this paper. A lot of authors. So that means that it's probably a lot of work probably went into this, which generally means that it is the culmination of maybe a few papers that the authors were publishing. So this is probably really interesting, but also Azure Storage, it's some production use case. Azure is a public cloud. So this seems pretty interesting. I also was very interested in this one, which is another paper related to RDMA from ByteDance. So ByteDance has, bottom, okay, let's see, bottom, Ahmet. Thank you, Ahmet. Bottom part of the screen is not visible on the screen. Okay, let's see if I can, let's see if this makes it better. And let's actually do this. Let's try doing this. Awesome. Yes, my first great success. First time responding to feedback from chat. Thank you, Amit. Okay, so yes, where were we? This looks like an interesting paper. GPUs. None of these really caught my eye, but that is mostly because I am not really an expert in this area. I thought, I'm interested in applications where we can harvest resources that are underutilized. So and as a result, efficiency gains or cost savings. Those are generally very interesting because there's very clear value to that type of work. So 5 concurrent viewers, we're trending up. Amazing. So this is interesting to me. Again, more ByteDance. So I actually probably won't go through all the papers here because this is Monday and there were 3 days of a conference and there are a lot of papers published. So we probably won't go through all of them. But let's scrolling down to a few of the other tracks. A few of them caught my eye. I actually didn't include this one in the list of papers that I want to read, but it's written by Google and they do very interesting systems research there generally. So I will add this to my list of papers. And I make a list of all the papers that did not copy nicely. And I use this note-taking tool called Roam, which is very helpful for organized. It's very helpful for my brain taking notes. I like to take notes on the papers. So today we'll spend a bit more time looking at the papers and just give you an idea of like, how do I approach actually finding papers, and then we'll read one of them together. So yes, there is a track about video. I was very interested in the one that was related to I think it was this one about video analytics at scale. Super cool. So I like to read that. I wanted to read that. Data, none of those really caught my eye. This was a paper that I was really interested in because cluster managers are a really important core technology that they're really important core technology that are used for running jobs somewhere in a data center, or they like to say warehouse scale computing. So just generally very large scale. Cluster managers could also be something like Kubernetes as a cluster manager. But then there are ones that exist in industry, like Borg from Google, or Twine from Meta, or there is a Mesos, which used to be used in production by Twitter, although maybe not as much, and also used to be used by Apple. So not sure how much Mesos is still used. But anyways, cluster managers are really important for running jobs at scale because you have to be able to say, I want to run some application over many computers using storage, using memory. Okay, figure that out. And the cluster manager can just go, I have these machines, and that is just a core competency that you need to run jobs at scale. So anyways, I previously wrote about this because there was a cluster manager. Omega is the other one. It's from Google. So anyways, cluster managers, pretty cool, and they talk about how to tune a cluster manager like Kubernetes and does things automatically. Automation is awesome. So that seems interesting to me. So I put this in the papers that I want to read about. Let's see if there are any other ones. This is another one from YouTube about the YouTube content delivery network. We're using YouTube right now. Very interesting technology that just works at scale. So they're doing something related to their eviction policy for their content delivery network. So something that makes all of the videos essentially be able to be served at scale. You have this content delivery network. Very cool. So that's another thing that stuck out to me. Yes. There are this track, there wasn't really anything that stuck out to me. There's this is alternative networks. Like they're doing some futuristic integrated space and terrestrial networks, which seems pretty cool. Pretty far outside my wheelhouse. So I put it on the list of papers that I like to read, but a bit farther down. Then, yes, I think that's it from this track. So we'll just look at the papers for about 5 more minutes. So what else did I see here? Another paper. Oh, there are actually 2 papers here that I was interested in. One is called the sky plane. So there's this idea that you have cloud providers, and we have cloud computing. However, we want to if we are using multiple cloud providers, that is actually sky computing. And there was a paper by, let's see if I can find it, sky computing. It was by Ian Stoika and Scott Shankar. Let's see if I can, here it is. Very interesting paper about, how can we, and also many of the cloud providers have similar technologies. So how can we basically write code that is agnostic to which cloud provider we are using, so not using a single cloud provider, and that's actually simplified because we're using, again, coming back to cluster managers, maybe we're using Kubernetes or using some other tool. So Sky Computing, very interesting. There are actually 2 papers from, where was that? Is it here? Yeah, there are 2 papers from that lab from Ian Stoica related to this idea of Sky thing. So there's Sky Plane, which is about transferring data between clouds, and then there is also Sky Pilot, which is some, I haven't read the paper, but is something about helping computation between different clouds. I haven't read the paper, so I won't pretend like I know what it's about. But they're both related to this idea of sky stuff, multiple clouds. The other paper that caught my eye here was about using this technology called eBPF, or Extended Berkeley Packet Filter. Filter or filtering? eBPF. It is filter, Extended Berkeley Packet Filter. So basically, eBPF is a technology that lets you run code inside of the kernel and inside of operating system kernel, generally on Linux, and do something faster, because you don't have to make transitions between user space and kernel space. So eBPF has been used for, and maybe you can access kernel data structures as well. So it is very helpful for monitoring things in the kernel, or maybe in this case it's doing something faster because you're not making transitions between the kernel and user space. So it seems pretty interesting. eBPF has been used for a lot of other things, and actually Jevons. Yeah, nice. It's in my history. There is a thing about eBPF from Julia Evans. She has a blog that she has a blog that I really enjoy. Very educational. So she talks about BPF and eBPF. So very cool technology. It keeps coming up. I think that is okay. So we're about 20 minutes in. Surprisingly 20 minutes in, but we did start recording previously before I actually started talking. So let's just see if there are any other ones that were interesting here. Yes. So this is another author. This is an author that I recognized, so I was interested in their research. Tianyan is active on Twitter, and he's from UC, University of Illinois at Urbana-Champaign, and they have this tech project about automated reliability testing, which is really interesting to me because, if we're able to just automate this testing that we're doing, can we save cost or test more things potentially if we are automating failures or introduction of failures? So really cool. So I think that's probably it for the looking at papers. I've actually created a whole list of papers that I was interested in. Let's see, is this big enough? Chat? Anybody? Anybody? Okay, seems like it's big enough. Yeah, I really messed up. really messed up the streaming configuration. That's pretty funny. So that's my lesson for myself. Can I even I need to tweet out the right link first time streamer. Does Twitter not let you do this emoji anymore? How come you can't do smiling face sweat emoji? Oh man. Let's see. Twitter, what are you doing? Okay. Like and subscribe. Okay, so now let's go back to this. Okay, so yeah, I talked about some of these papers. I think the one that we'll read today is actually Invisinets, removing networking from cloud networks. So this seemed fairly interesting to me, and it was by a combination of authors that I recognized. So I recognized actually Sarah McClure because I'd read some of her research previously, and then also there are folks from Google and UC Berkeley and Microsoft. So people from industry and academia. So that's really cool to me. So yes, everybody like my fix tweet. Everybody like my fix tweet. Okay, so what I do, there's a very cool, YouTube embed obviously is in here, but we're not gonna watch the video, so folks can do that on their own time. But generally it is very helpful to watch the actual talks because they give some quick overview of what the research is about. So this is the paper we're gonna read. Let me post it in chat. Okay, so let's do it. I'm going to download the paper, and then I like to use the tool called Zotero. So let's see, 1 second, let me go find the Zotero. Let's bring it over. Okay, we got the Zotero. And this is, I really like Zotero for taking notes, and I'll show you why in a few seconds. So, we can import the file, and then it adds a lot of metadata about the paper. So it just parses everything from the PDF. Zotero, amazing. Love Zotero so much. Okay, let's see if we can enhance. Okay, so now it's loading. Okay, so there are a few things I like to do with Zotero. You can highlight. Ooh, amazing highlighting. And then you can also make things different colors, which is very cool. So I like to do that to provide notes to myself. And then I also like to take notes. while I'm reading the paper. And I generally do 3 passes of a paper. So let's actually do this, and I'll open up room, actually, it's right here. And then a room, I do this. So I have this little template. That I use to take notes for paper. Roam is a knowledge organization tool. So I have some metadata, and I copy all the metadata in. And then I generally look at a few things. So can folks see this? Let's see. Okay, that's cool. Sec. Okay, I just want to make sure I have the live stream up because people may provide comments, and I want to make sure that it is yeah, okay, cool. So there are a few questions I like to answer. What is the research and why does it matter? One of the most important questions, because otherwise, you know, why even do research if it doesn't matter, right? So there must be some reason that the authors thought they should work on this, and it's not just to get a PhD. How does it work? So if there's some technology or some algorithm, how does the algorithm work? And I like to try to explain it in the dumbest possible way for myself when I'm taking notes. Like, okay, it works because this step, then this step, and this step. Try to like really explain it in the simplest possible terms for myself. Then how's the research evaluated? So for example, does the research, you know, is there some, I would say, you know, some empirical look at the research, like they've been running in production for several years, and that is great because they've been able to get some data source that says, oh, yep, it's way better than the thing we had previously. So how is the research evaluated? Most papers have some evaluation. If they're systems papers, sometimes algorithms don't necessarily have that. So if they're just theoretical. And then I like to have some conclusion, which is, what is my take on the research? For example, can I connect it to something else? Do I believe? Most of the time I do believe what the conclusions are of the paper, but not always. So do I buy what their conclusions are? Do I have any questions, or is there other research that I would like to follow up on? So I like to do that with the conclusion. This is also heavily borrowed from the How to Read a Paper. I think there's a famous How to Read a Paper. How to Read a Paper. I believe it's computer science. When I find it, I'll see it. Yeah, this is the famous one. So S. Keshav wrote this, and it describes a few things about reading scientific papers. And I've borrowed a lot from this methodology, but not 100%. I don't follow this to the letter. And I also have, I'm trying to write about the paper, and that's partially to just make sure that I understand. It's very helpful. Writing is very helpful for me for understanding. So yeah, there's some questions here. The 5 C's, that also is in the How to Read a Paper. Some of these are duplicative, but generally a good way of figuring out what what you should take away. And then I tried to do 3 passes. So the first pass, I think this is actually so this is actually borrowed from How to Read a Paper. I'll do first pass where I just try to understand what they're writing about and what the motivation is. And generally, if the paper is well written, then you can answer these questions. Sometimes the paper is confusing, or it's just so unknown that you can't actually read the paper at all. Like, oh my gosh, before I read this paper, I have to read like 5 other papers. That happens sometimes. That happened to me with the Azure RDMA paper, which we're not reading today, but I'll be writing about next. I was like, oh, I have to read like a few other papers that they've written about RDMA or how they're using congestion control. It's like, oh, okay, I want to go read this other paper about their congestion control that they're building on top of. So yes, first pass, generally try to do it in 15 minutes. I will read the basics of the paper, and I don't read actually any of the details in the internal of the paper. Then I also look at if there are any papers in the references that are interesting to me. So this takes 15 minutes, and I actually use a Pomodoro timer to time myself, because I generally try to do this fairly quickly. Then I will go through all the sections, second pass, and I will be a bit more meticulous. I'm actually reading the subheadings, reading everything, basically. Oh, cool. Yes, Rome. Yes, I love Rome. Hello from Mapbox. I used to work at Mapbox. They make very cool maps. Welcome to the chat. So, yeah. So, yeah, I like to use Rome. It's pretty cool. You can do a lot of cool stuff in it. Like, I'm actually not probably as much of a power user, and actually Rome has some competitors now that has like Obsidian, Workflowy. There are a few other things that are Rome-like rather, but I've used Rome for a while, so started using it over the pandemic, I guess. And it syncs across devices. You do this, woo, checkboxes, amazing. Pomodoro timers, amazing. So yes, second pass, I will do some of the things that are noted in the How to Read a Paper, like looking at the figures, trying to really understand what the paper is about, what they're doing, and trying to start answering some of these questions in a deeper way. In particular, like, how does it work? Oftentimes you can get what is the research and why does it matter here, but then the how does it work, in particular, if I don't know something internal about the internals, like, oh, they're using some algorithm that they're citing. Oh, everybody knows what that algorithm is, but I don't, because I'm not a subject matter expert. So that's kind of where you like fall down the rabbit hole when you're doing the second pass. And then the third pass, what I will do is that's actually when I start trying to write. So I will try to, I've taken notes, and I will just try to brain dump my understanding of what the paper is about and try to write it in a way that is not going to be the final draft, but I have to do some thinking about how to express the ideas. So that process is very helpful. Otherwise you get writer's block. So I just will go down the paper and try to summarize what I've learned from it and how I think it works, and basically taking my answers to all these questions and putting it in the paper, or putting it in written form. We're not going to do writing today because that generally is later. I like to actually sit with the paper for a while. like do first and second pass. I'm not doing a PhD, so I have the luxury of doing the first and second pass at once, and then third pass later, that writing pass later. Also gives me a bit of time to think. So, okay, so now we're going to do the first pass for Invisinets, removing networking from cloud networks. Let's see, how long have we been going for? 45 minutes. I think we're going to be, I'm actually going to get some more water, and then be back in 5 minutes. I really should have a loading screen for this, so I'll be back in 5 minutes. All right, we're back. Lighting isn't too bad. It was 2 minutes faster than promised. So, also, if folks have thoughts about what papers to read, please message me. In the past, Amit has messaged me papers. Amit B on Twitter, and actually, is that Amit's actual Twitter handle? Amit B on Twitter. Yes, that's correct. So feel free to message me. I'm thinking about whether to create a threads. Should I create threads? I don't know. we'll see. Okay, cool. So I think we can get started on reading the paper. Okay. So I like to do a few things. Highlighting. I have a yellow for, that's interesting. Red, what? That means like a what? I don't understand. So come back to this. Then I have a few other colors that I use less frequently. And actually this is very helpful for me to understand, like how much of the paper have I actually gotten on the first pass? Because you could just scan the recording, or the highlights, and you're like, oh wow, there's a lot of red. I understood absolutely nothing. Have to do a lot more research. And then I see blue is like oh, that's interesting. That seems related to something I read previously. So if there's some networking thing that is related to Clos topologies, for example, because I've written about Clos topologies in the past on my blog when I was talking about the the Google networking, Jupyter. How does Google network work? Then okay, wow, it's related to Clos topologies. That seems good to know that, because I want to call that out. Also, if there's some point that I want to make. So actually, a lot of my writing, I will try to make those connections, because I think, as someone said, and I do feel it is AI. You can just give a paper to AI, and it will, some LLM, and it will summarize the paper. But it's really making those connections to other content that I think is where I can add a lot of value, and that's where, I learn the most if I'm making connections to other things. So I try to actively do that. Okay, so, and also the paper is, let me share the link, just to make sure I shared the link, Invisinets. Here it is. This is the actual PDF. Oop. Okay, cool. So, wow, we're at 7 people. Amazing. That's pretty good for the first time. Oh, I like that. Yeah. Okay, so I've never actually read the paper with somebody looking over my shoulder, so this will be interesting. But I'll try to talk out loud while I'm reading it. So, networks are complex to configure. Yes. Aha. Cloud. As these networks are increasingly spanning multiple clouds, aka sky computing, I'm not surprised to see that, because I think Sarah McClure is, yeah. So these people are from Berkeley, and Berkeley has this lab with Ian Stoica. Is Sarah McClure actually in the, that's not the right results. Berkeley, maybe, oh yeah, okay, so yeah. So okay, yes, this actually makes sense, because Sarah McClure is a PhD student in the NetSys lab at UC Berkeley, and Scott Schenker is working on, he's actually one of the people who wrote that paper about sky computing with Ian Stoica. So that makes sense to me, that there's this common thread. And you actually see that a lot of research, like, especially if there's like the PI or the head of the lab is there's some theme that they're building on, there will be students or other contributors from the lab who will be working on that theme, or have ideas that are on that theme. So, and that's, maybe they join the lab because I have never done a PhD, but they joined the lab because they were interested in that theme, for example. So, anyways, I don't know Sarah. Maybe at some point I will reach out if she has a Twitter account, and then we'll have a discussion about the paper. That'd be super cool. So, we argue that the current okay. So I'm curious what they mean by the tenant networking layer. It means tenant networking layer of cloud deployments altogether, placing its forward duties. So I guess my takeaway is that they're trying to build some configuration thing, which is reducing complexity in using multiple cloud providers or using networking tools. That's my takeaway from the intro. That's what this says. Okay. Okay. Yep. That is the Sky computing idea. Oh wow. Yes, this really resonates with me. For folks who have ever tried to use cloud networking, oh my gosh. Like, how I think that there's some wizards now that are actually very helpful, but it requires a lot of domain expertise. I'm not sure what color to use besides, I think this is yellow. But oh yeah, you have to subnets, you got your gateways, you have your so much networking stuff that you have to configure, and it's kind of troublesome. You need to be an expert. It also differs per cloud provider. Security in particular, super difficult. That's what they talk about here. Okay. Publicly routable but default off addresses for all endpoints. Okay, so they're making some assumption, which is that they simplifying assumption, which is that the traffic is allow listed, and that makes things simpler, question mark. SLOs, okay. So SLO stands for service level objective, and it's very service level objective. It is something, let's see, popularized by Google SRE, which also happens to be where I work. And they are basically some way of measuring performance. So I linked what SLOs are in the in chat. So they develop a new API. Ultimately, this results in declarative associate SLOs to endpoints. Okay, this seems reasonable. I don't really understand this. Ultimately, this results in a declarative approach. I understand the declarative approach, But I don't understand essentially associate SLOs to endpoints. So okay. Okay, cool. Okay, cool. So now we're getting into the motivation. Let me shift my screen. Now we're getting to the motivation. So they're saying, okay, there is a reason that things were this way. And the reason is that I'm like an LLM. Am I better than an LLM? What does the chat think? The reason that things were complicated is because people had on-premise stuff. They had some infrastructure that was deployed in the data center that they controlled, but now they're not really doing that anymore. So this complexity is unnecessary. So that seems important. So, oh yeah, I remember I used green for motivation. Okay. More motivation. It's not just, I really like this paper already. I really like this paper already because they're talking about, and let me go to my notes. Because they're talking about why, like, okay, you could do this thing theoretically, which would be good for customers, but it's not just good for customers. It's also good for the cloud providers because of reasons that they're going to talk about. But I think that's really cool because you can imagine that if they're able to say that, oh, this is a standard that is good for cloud providers, there's some API, then the cloud providers would implement that API and maybe actively support it versus having some community thing that exists outside that is only maintained by the community. So I think that's really interesting. Although I'm not sure that I believe this part. That may not be true of all cloud providers, in my opinion, but it's still interesting. Fewer mistakes. Again, I'm not sure that I disagree. You might say that some cloud providers want their people to use support, but yeah, I don't know. I should probably use a different color for, I'm not sure. Maybe orange. Oh, actually, that's not very colorblind friendly. Magenta? Gray? Gray, I think, is best. Okay. Okay, another thing about the introduction is that I didn't time this. I should have timed this. But they talk about, oftentimes many papers will talk about, oh, this is what's in the rest of the paper, which is very helpful. So implementation, evaluation of new API, Invisinets, cool name, for tenant networking. Oh, workshop paper. Okay. So they're referencing some workshop paper. I try to make notes of this. So on the left side, introduction to do what is the workshop. And then, because I'm using Rome, I can do this. Woo. I'm not a Rome evangelist, I promise. Get this little to-do box. Okay, so then we have. Okay, cool. Complexity. Okay, that's how they evaluate the paper. Based. Oh, chart trending up. Viewers, where are these new folks coming from? Cool. So I think complexity generally is difficult to measure because how do you measure it? Like, is complexity, so I'll be curious to see what they actually measure in terms of, yeah, I'm sure how do they measure it? For example, do they measure it in lines of code? Do they measure it in time spent developing? Do they measure it? Ideally, there would be some measurement of complexity that was like problems found, right? That's like the real ground truth. If you deployed some system, it's like, oh, this because we're using some simplification, we don't have these security problems, or we don't have availability or scalability problems. So that would be ideal, but I think maybe the research isn't yet at that place. So anyways, so I think we can actually effectively answer some of the 5 C's. So what type of paper is this? It's a research prototype, right? There's a workshop paper to read Sky computing paper, and then I think that's it that we know about so far. Do the assumptions appear to be valid? I'd say yes, right? Right, yeah. Seems fine. I don't really know enough about the research yet. Yes, they seem to be building on. And then we'll get to the contributions later. Generally, papers have spelled out, these are the 5 things that the contributions are, these are the 5 things that the contributions are, right? Like, oh, we developed the system, we developed a way of testing it, we evaluated it, maybe some other learnings sometimes. So there are generally 3 types of contributions for systems papers at least. So anyways, what are the paper's main contributions? We'll get to this, and then is the paper well written? Yes, I really like this paper, actually. Super well written, very clear. That's awesome. Okay, so now what do we do? So I go through my notes, and then I have motivation. So imagine if I had an LLM do this. Problems. I basically take notes by section. Chart tending up. Another person has joined the chat. Amazing. And what else is there? So then there's the approach. What else? Oh, this looks very interesting. Okay. PRDO addressing. Notice how I'm not reading any of this yet. Apply to Invisinets. Security. As we go, I get lazier and lazier with how I type out the headings. API design. Yep, evaluation. Oh, implementation. Yeah. Okay, there's some case studies. Terraform. Ah, they're using Terraform? Okay, I was about to say Terraform is a thing that, let's see, so I should actually be, is this better? Terraform, yeah, okay, this seems like Terraform. Terraform is a way of writing configuration as code. Terraform.io. So basically, that means that you have, let's just show an example of what Terraform looks like. Terraform? Or I could even, let's see. Let's see, maybe if I have to go to GitHub. Terraform. What? Okay. I want to see some usages of Terraform. Samples. Okay. Samples of Terraform. Okay. Integration testing. They have some Terraform thing, which looks like this. And then you can specify different resources and then have variables. It's not very instructive, but okay, you can configure stuff like where your resources are created. They actually probably have some better docs. Let's see, policy as code. Manage Kubernetes. Let's see. Oh, okay, they got some pretty cool stuff. They got docs, that's what we want. What is Terraform? Configuration language. Yeah, so there's some configuration. Aha, they're even configuring networking here, right? That's exactly what the paper is about. It's configuring networking. But yeah, networking stuff. VPCs, oh my gosh. Virtual private clouds, that's what VPC stands for. There's so much networking stuff that you have to configure. So I'm curious how they use networking or use Terraform. Okay, so now let's go back to this. Okay, so Terraform complexity. Let's still take notes. Okay, Terraform complexity, scalability, limitations. Aha, limitations. That's going to be interesting. And then the conclusion. So I read the conclusion, and then I read the final. I read the references at the end. So let's see the conclusion. Okay, so they're trying to simplify this configuration, but there are some shortcomings. Okay, this is very cool. It can coexist with the existing abstractions, which is very cool because that allows people to put into practice what the research is. Like, oh, we have this idea of codifying this thing, building this API. And if it's difficult to onboard that idea to your existing technology, then you won't. So there won't be adoption of whatever your idea is. So I think that's cool that that's something they've considered. Interesting. Okay, so they're making some claims about simplicity. New systems should be easily scaled. I'm not sure what that means. Okay, so now those are the references, or sorry, we'll read the references. A bunch of stuff related to tooling, it looks like. I'm curious, yeah, something I want to see in the references is where do they think that this is a problem? Like, is there some research that talks about this being a problem already? maybe. Network configuration verification. This is a paper I've wanted to read, but I haven't read it. So I will. Oh, yep, another paper that I want to read about maglev, which is Google's software network load balancer, which is supposedly very cool. But yes, haven't read it yet. So, this is a paper by Anthos, about Anthos, which is the Kubernetes sky computing thing, as far as I know. Orion, another cool paper that I wish that I would be able to read, maybe soon. Orion is Google software-defined networking control plane. Obviously, that's what it says in the title of the paper. What that means is that you need this system to control the networking devices and tell them what to do in your data center. So you have the control plane, and it ingests all this information and then makes decisions and then tells the routers, tells the networking equipment what to do. So, do not scale, very difficult. Would be a really cool paper to read, maybe in the future. Before, I know that I want to read this paper, but I haven't. It's about Google's network again. This seems interesting. Validating data center at scale. That seems. I think that seems pretty cool. Okay, I think that actually seems related to the motivation. Static checking for networks. That seems interesting, but also fairly old. Okay, so this is the workshop paper. So definitely read this. These seem interesting, but not super relevant as far as I can tell right now. This is talking about SLOs. So I'm curious what, or nines are not enough, indicates to me that it's nines are not enough, indicates to me that they are probably talking about SLOs and metrics also. So this seems interesting. Yeah. Ananta. Rate limiting. Oh, maybe Elon Musk has read this paper. He's in rate limiting Twitter. Cloud control. I don't think so. This is the paper that I wrote about. Jupyter Rising. MikeLeonard.com. Sorry, let's close all these tabs. Jupyter. Rising. Okay. So, okay, we're going back to here. I think that's probably all I would read. From cloud computing to sky computing. I mean, this is really important because this is related very closely to probably where this is coming from. Cool. Cloud for outage. That seems interesting. Okay, let's see how we're doing on time. So we've been going for an hour, 19 minutes. So I think what we'll do is we'll probably do a quick skim. We'll do a summary of what the paper's about, try to answer some of these questions, and then maybe we will do the app, because we spent a lot of time actually talking about how to even read papers or how to find them. So I think maybe we'll stop after. I have limited first time streaming. I've limited, I'm not sure. It's gonna take some training. Can you imagine that people stream for like 8 hours a day? Unbelievable. Streaming is difficult. It's a real job. So I think what we'll do is just write down the answers to the first few questions, and then that's probably it. All right. So I think let's try to answer. Okay, so what is the research and why does it matter? So I try to do this in a very like stupid, simple way first. Let's see. Stupid, simple way for me. So networking I spell specialty. Making it simpler, reduces availability problems, reliability in general. I think this is the claims they're making. And then how does it work? They built some API that allows you to specify network configuration and end up with something that's auto-generated. We don't know the details yet. And then simplicity through case studies. There are a few other ways they evaluate the research. And I don't have any conclusions about it besides the fact that I like the research right now, because it's it was very easy to read. So I think that's actually probably where we're gonna end. And maybe we'll come back on like Tuesday next week. Try to Tuesday probably, and then read the rest of the paper. So I think that's actually a good stopping point. On that note, thank you for attending the first stream. Stay tuned. Feel free to send me feedback on Twitter, or I don't even know if YouTube has DMs, but try that. That's all. See y'all.